Okay, here's warm-up number 19. We've got a quadratic function here that we're going to rewrite in vertex form. So there's two ways to do this. One way, the way I'm going to do it, is by completing the square. You could also just find the vertex using the axis of symmetry formula. So you could do part B first and then build the equation in vertex form. That would work too. Okay, but yeah, let's use, I'm going to complete the square. So I'm taking this function and I'm going to find the mystery number so that I create a perfect square trinomial on the right side of the equation. Negative 12 is not the mystery number, so I want to move the negative 12 over the other side of the equation. So I'm going to write it like this, okay? And I'm leaving some space before my equal sign. But then I've got x squared plus 16x, and I'm going to add in whatever my mystery number is. Okay, and since I'm adding it on the right side, I have to add it to the left side as well to balance out the equation. Okay, and then there's a little formula for the mystery number that's going to go in both these positions, and that's b over 2 squared. Okay, b here is 16, so I've got 16 divided by 2 and then squared. That would be 8 squared, which is 64. So the mystery number then is 64. Okay. On the left side, I'm just going to combine these two into 76. On the right side, I'm going to factor this. And keep in mind, this should, since we're completing the square here, this should factor into something times itself, something squared. Okay, so really I just have to figure out what this is. So you can do a little diamond problem if you like. Looking for two numbers that add to 16 and same two numbers multiply to 64. That would be 8 and 8. So there's the right side of that factored. Okay, and then all I have to do is isolate the f of x. So that means just subtract 76 from both sides. So I've got that squared binomial, and then I'm going to subtract 76 like so. Hey, now it's in vertex form. And if you're familiar with vertex form, it makes it pretty easy to find the vertex. You just take this part, set it equal to 0, and that will give you your x coordinate, and then this is going to be your y. And now I've got the coordinates of my vertex. So my vertex is going to be the point -8, -76. Okay. All right. So let's try another one here. I'm going to solve number 2 by completing the square. So completing the square, you really want to have your x squared term. You don't want a coefficient attached to it. So there's a number of things you can do. The easiest way to deal with it is to just divide it out of the equation. So since this equation is set equal to 0, I can do that. I wouldn't have wanted to do that if I had a y on the left side of the equation, because then I'd have, if this was y, I'd have y over 5. I don't want that. But if I just divide everything by 5, then I'll have an equation where I've got my a is 1. The x squared coefficient is 1. Okay, 0 divided by 5 is 0. Let's see, -6x plus 11. Okay, and now I'm going to complete the square the same way I would with any other problem. Sometimes you end up with fractions, which is a pain, but you could still complete the square. Here we don't have fractions, thankfully. Okay, so I'm going to look for the mystery number, which isn't 11, so I'm going to move the 11 over to the other side. Okay, and since I'm going to be adding a mystery number to the right side, I'm going to be adding it to the left side as well. Okay, and then let's use that same little equation, b over 2 squared. Here b is -6. So my mystery number is 9. Okay, so I just do the arithmetic on the left. On the right, I'm going to factor this, and if I pick the right mystery number, it should be something times itself. Let's see. Yes, it is going to work. Something times itself. It's going to be x minus 3 times x minus 3. Okay. So now that I've got it set up like this, I can complete the square. So I can take the, well, I already completed the square, but I'm going to take the square root of both sides. That's the point of this. Okay? So now when I take the square root of the right side of the equation, I've got just x minus 3. Okay? On the left side, don't forget the positive and negative. Okay? And I've got it written like that. Let me zoom out so I can stay on screen here. I want to isolate the x, so I'm going to add 3 to both sides. So I've got 3 plus or minus the square root of negative 2 equals x. Okay? The square root of negative 2 isn't a real number. No real number times itself equals negative 2. But we can still write this as I root 2, right? The square root of negative 1 is I, so this would be the square root of negative 1 times the square root of 2. So I can rewrite this as 3 plus or minus I root 2. And in the past, we might have written no solution when we got to the square root of a negative number, which there's no real solution, but once we've covered imaginary numbers, then we can write this as an imaginary number like so. Okay? All right, last problem. We're writing an equation in slope-intercept form, so that is y equals mx plus b. Okay, it's going to be through this point and perpendicular to this line. So I like to set this up with my old line and my new line. So the old line is the one that's given in the equation here, 4x plus 5y equals 2. And that's going to be perpendicular to the new one, the one that I'm actually writing the equation for. Okay? So first thing I want to do is find the slope of the old line, because the slope of the old line is going to lead me to the slope of the new line. So let's subtract 4x from both sides. I'm trying to put this in y equals mx plus b form. So I'm going to slip the negative 4x in front of the 2 like so, because now I'm getting closer to y equals mx plus b. Okay? Then I'm going to divide everything by 5. Okay, so now I can see the slope here is going to be negative 4/5, and that's the m part in y equals mx plus b, right? If these were parallel lines, my new line would also have a slope of negative 4/5, but since they're perpendicular, the perpendicular slope of this is going to be the opposite reciprocal of this. So I'm going to flip it upside down and change the sign. So that means 5/4. Okay, so the new line has this slope. I also know a through point for the new line. Okay, so let's think through this. We're writing an equation, y equals mx plus b. So far, I already know the slope is 5/4. So I still need to figure out the y-intercept, the b. And what I'm going to do is I'm going to use this xy pair and plug it into those two positions. So I'm going to put in 3 for y, and I'm going to put in negative 2 for x into that equation. And I should be able to solve for b now. Okay, so 3 is going to equal, this would be negative 10/4. And hey, negative 10/4 is going to be the same as negative 5/2. Well, just so I don't lose any one, I'll write it like this first. And reducing that fraction, there we go. Okay, now I'm going to want to add 5/2 to both sides. But before I do, I might as well get a common denominator. So I'm going to rewrite this as 6/2 so that I can combine it with the 5/2 when I add the 5/2 to the other side. So 6/2 plus 5/2 is going to equal b, and that means 11/2 is b, or 5.5 would be fine too. Okay, but now I can write my equation. I already knew it was y equals 5/4 x plus something. Now I know what that something is. Y equals 5/4 x plus 11/2. Okay, and that's it for today. See you next time.